In 2016, Maverick Applied Science developed the Plant Engineers FRP Forum to create a platform where plant engineers could come together for in-depth discussions and to improve their work and knowledge of non-metallic piping and equipment. After the success of the initial Plant Engineers Forum, Maverick decided to offer this training yearly. The third annual Maverick Applied Science FRP Plant Engineers Forum was held on May 9th and 10th, 2018. This year's forum included presentations by key Maverick employees, along with a broad group of industry leaders. This year's topics included what proper non-metallic equipment purchasing specifications should include, how to choose the proper materials and manufacturing methods, how to design internal structures, and how to choose the correct codes and standards for fabrication of your non-metallic equipment. Finally, we also included some inspections of non-metallic equipment. Since everyone was not able to attend this forum, Maverick would like to share some of the offered presentations to the public. Thank you for your interest in Maverick Applied Science.
The focus of my presentation, this first presentation this morning, is an impactful tank specification. And what we see is that most corporations, whether you're an engineering company or you're an owner end user, almost everybody has a set of specifications. In a lot of cases, once those specifications have been done, they're set in stone. So we see a lot of specifications that are maybe 10 years old, 20 years old, 30 years old. And once they have them, there's not a great urgency to circle back, or it's a lot of cases I feel like it's just a matter of dedicating resources. Everybody's got time and personnel is kind of the fixed assets in the plant when it comes down to it, and where do I spend my time? So a lot of times specs are an easy thing to overlook because there's always a hotter fire out there that's got to be addressed. Something that is very time sensitive that has to be taken care of today. But what we have found is in the last, I'd say, 5 to 10 years, there's been a lot of FRP done out there, and FRP continues to grow. And what we find is there's a lot of lessons learned through all of that, but it doesn't find its way into the specifications. The specifications or the specs, they're same way they were in 1995, and you lose a lot of benefit. There's things that you can put in the specs that will save time, mitigate potential issues that you can define in the specs, and then everything is crystal clear. And if you define expectations up front, then the goal is that everything runs smoother, you get a better part, better installation. So I'm going to talk kind of about a little bit about your basic specs, and then we're going to kind of get into some more details. So we're going to talk briefly as a overview specifications of the past. What are the needs of today in specifications? We're going to talk about some of the tank references that you'll see in very typical specs, some of the basic requirements, which most of you probably have some handle on, and then also what we expect to find in specs. And I'm going to ask you kind of what you're used to seeing in specifications. And then I'm going to kind of hit some new bullets of things that you need to think about having in specifications. Here we go. So here's kind of the sort of the fundamentals of a spec. So you want the spec basically. I'm kind of giving you an example here, and this is just a single page, but it wouldn't be uncommon if you go back 10 to 20 years that a spec would be about 3 pages long a lot of times. Maybe 5 if it was filled out a little bit. It's going to define the fluid contents. So this is basically the chemistry, all the different components within the fluid, service conditions, pressure, temperature. Sometimes there might be an upset condition, but not always. And then the design standard, it'll just say ASTM D3299, or maybe it'll say RTP1 or Boiler and Pressure Vessel Code Section 10. And that'll be it. And then beyond that, materials of construction. So it'll say fiberglass, dual laminate. It'll say if it's dual laminate, there's a liner and what that lining material is. And then method of construction. So it'll say, filament wound shell, something like that. And really just kind of defining the basics. And then quality will say level 1, level 2. I have actually seen specs that say level 3 on them. Once you kind of get into this and get intimate with the specs, but basically level 1, that's defined in the spec, that's pretty close to perfect, especially if it's on a corrosion barrier. The new standards, the way they're defined, they actually will go into detail of what level 1 means, and you can kind of come to an agreement with an owner. But basically, it's a near perfect corrosion barriers where you see it the most. Sometimes the structure, if you ask for perfection in the structure, they're going to challenge the fabricator some. Level 2 allows for some small defects, but on a very limited scale. Level 3, if you see that in a spec, beware, because that means pretty much everything goes. There's almost no limitations of what level 3 could be. You could have something this big in a level 3 laminate, and it might be okay. So I'd encourage you to stay away from that. And then beyond that, it talks about standard spec. We always talk about testing what the hydro looks like, how many hours and that sort of thing. So, one of the things that we're finding is today's needs are a lot different than they were 10 years ago, or definitely 20 years ago, or even 5 years ago. All of us are asking to run harder, faster as employees of companies, including myself as a company owner. Pretty much I work for y'all, so I don't feel like I have a whole lot of freedom and independence all the time. But expectations are higher. Plants, we are asked to design equipment on plants, and they say, well, the plant life is 15 years. It's like, really? I've never seen anybody mothball a plant after 15 years. And you look at power plants, you look at some of these chemical process plants that are out there, and they're going back to the 50s, and some of them even to the 40s. So if they say 50, or 15, when it gets to 15, they're just going to push it out and say, okay, we're going to retrofit everything, update, and we're going to keep cruising. So today, when we're really looking at materials, we need to pick materials with those kind of expectations. So we need to kind of look at the bigger view. And outages are kind of the same way. If you go back, 15 years, almost every plant had an outage every 12 months. It was set in stone, might be 2 weeks, 3 weeks, but it was this time of year, second week in October to first of November, and they went through the plant, they took care of everything, came back up, and everything was good. Now it's like, well, can we run for 18 months? Can we run for 24 months without a break and stop? Outages are getting longer in some cases, so when they're up and running, they want to cruise. They want to be productive. When we talk to plant owners, and we talk about material selection and how you view it, we say your job is to generate electricity, or your job is to produce chlorine or whatever other chemical it is. It's not to maintain equipment and deal with unplanned outages. So the goal is to select, vendors and material and equipment that are going to meet those expectations. Everything else other than what your primary goal is a distraction, is a disruption. So we want to eliminate those. Then obviously, every year, if you go back, or for the last couple of decades, safety is an increasing priority in plants and society as a whole. That's always a growing concern. At every plant, no matter what kind of plant it is, you have, tremendous, equipment, huge equipment, rotating equipment. You have highly hazardous chemicals. There are great concerns out there, so the investments in quality of equipment and procedures on how they're run are definitely a critical part of that. We're going to go into pre-qualifying vendors. What obviously before you buy the equipment, time is short a lot of times, and everything is kind of on a press schedule frequently. We highly recommend that you do shop audits for particularly any major buy or large piece of equipment. You will learn so much about manufacturing as well as about your bid list. When you go into the plants, you look at the plants, you talk to the people, you see where they work, how they work, go in, review their documentation, look at their workspace. As an inspector, one of the things that when we walk into a plant and we're looking at the lighting, is if there's really good lighting in a shop, they don't want to hide anything. Matter of fact, they want to see everything. And if that's a priority, you already have a good feeling that they want to do a good job. And that's kind of half the battle, is selecting vendors that have the same priorities as you. And if everybody is taking pride in their work and working toward the same thing, usually you're going to get a pretty good product. But look at those kind of things, and that's kind of a starting point. If you go into a plant and you're seeing that it's very disorganized, there's dirt and dust everywhere, that's a little bit of a red flag. You want to see people who are productive, and you see flow in the shop, and kind of organized activity. Now, with tank standards, you have some basics here. You have D3299 is the ASTM standard for filament wound pipe. 4097 is a similar standard from ASTM, but this is contact molded. And then probably one of the main standards these days is ASME RTP1. Some of the principal differences is the first two are atmospheric standards, so basically no pressure. Now I think maybe I want to say the ASTM standards allow something like 10 inches of vacuum or something like that, but it's very small. Our TP1 goes to basically up to 15 psi on the top side and up down to full vacuum on the bottom side. Right off the bat, the majority of vessels today are not free vent to the atmosphere. They're connected to some kind of vapor collection system that's capturing the vapors off of some process. Usually there's if you look at the design conditions, there's a significant vacuum condition possible, as well as maybe 2 to 5 psi of positive pressure on it. So right off the bat, the first two wouldn't be in consideration. If you look at the details of these standards, you'll find that the first two standards are about 15 pages long in total. Principally, these are what I would call a product design standard. They define the calculations to basically design the tanks for these materials. RTP1 is considered a safety document by ASME. Largely, it's a quality control document. The design chapter is one of, 12 chapters and about probably another 10 mandatory appendix and non-mandatory appendix. So you're talking about 250 pages worth of document versus 15. So it's talking about material requirements, qualifications of the vendors. It's talking about details about the expectations of quality control, proof of all your materials down to certificates of analysis, a lot of detail about testing, substantial depth in expectations, and right off the bat, what you define as your expectations is what you're going to get. So to build the tank, there's a lot more than just the design aspect. So we would highly recommend using RTP1 for all of your low pressure applications. So here's some of your basic specs, and you'll see these requirements in a lot of specifications. I'm going to kind of run through them here. So again, defining design specifications, your reference standards. I just showed you 3 there that, in general, they're all a little bit different. What we see quite frequently, actually, is you'll see all those 3 listed in the same specification for one single tank. You'll see a filament wound spec, you'll see a contact molded spec, and then you'll see RTP1 on top of that. So as a manufacturer that's bidding on a project, which one do you pick? Well, if I'm really hungry that day and I need to put some food on my people's table, I'm going to say, which is the easiest one for me to comply with that's going to take the least amount of work? And that's the one I'm going to pick. So that's what, if you pick me as the low bidder, that's what you're going to get. If I'm a quality-oriented manufacturer, we stand on doing things right in the best way possible, and that's what we put our name on. I'm going to pick, say, RTP1 because everything is defined there. Everybody knows what that means, and it's going to provide the best possible product from a performance and a safety standpoint. And it's going to be 10% more expensive, something like that. But it's more important for you to have confidence in what we're going to give you than it is just being the lowest guy out there. So right off the bat, you're creating kind of a conflict situation where you don't really know what to expect now, or maybe you may not even understand that of, what am I going to get from bids and what am I going to get from a product, because all the quality requirements in RTP1 are not found in those other standards. So when you're writing specs, you need to define exactly what you want. Don't have everything that's got an FRP title on it as a reference document. What I would recommend, and what we try to practice, is if we have any ASME standard, any ASTM standard in a specification, there better be somewhere back in the body that we're referencing it. We're going to say flanges per this, and they need to be built this way, and here's the tolerances that we want that to be applied as defined in this. So don't, if you're going to list it as a reference, well, apply it in there and tell them how you want that applied. That's really how reference standards should be used, in our opinion. And then obviously your basic materials as well, whether your resin, your glass, your bales. And we'll talk a lot more about that throughout the next 2 days. Obviously, how it's going to be fabricated, you want to define that. What's the internal corrosion barrier, what's the external corrosion barrier. As Tom pointed to earlier, depending on how parts are fabricated, say it's a long, tall vessel that affords itself very well to filament winding, where you can make one long shell. It's all automated. You're going to get a very good product that way. If you've got a short shell, say you have a 12-foot diameter vessel, but it's only 8 foot tall, well, that really isn't well suited for filament winding, because when you're filament winding, the winder's going across, it's got to come square and turn around, and it's coming back this way. So what you have to do, what happens is you get these big buildups on the end. And so you get all this material in, the first thing they have to do is cut that off, because that's basically waste. The wind angle is changing there. It's not something that you can connect heads and bottoms to. So right off the bat, they're basically wasting and throwing away 20% of the material that they've had to put on the winder. So generally, if we get these kind of short, stocky kind of vessels, those are well suited for hand layup. So the contact molding specifications are approached, whether it's RTP1 or the ASTM standards, it's well suited for those. And so basically, depending on what the vessel, what its general dimensions are, kind of guides you as a manufacturer of which way is going to be the most cost-effective way to do that. Obviously, there's design requirements when we're talking about the drawings and calculations. And I just kind of put an example here. This was a company that doesn't exist anymore. Maybe there's a reason for that. But it's from the 1990s. You can't read all the detail there. It's really not that important. But well, when you get drawings from a manufacturer, you want to have all the details of the bottom knuckles, the head knuckles, all the welds, connections, how the bottom is constructed, how it's tied into the shell. All these things need to be on the manufacturer's tank drawings. When you have something like this, as a reviewer, you have no idea how they're really building it, how's it going together, are the welds thick enough, do the welds meet the standard requirements? So just to understand that there are expectations, and I guess the point is that you need to state what your expectations are. Shipping and handling. What do you ask for as an owner when you're buying a tank? Can I ask in general? I guess Pat, you're an owner. You bought quite a few tanks. Do you define how things should be shipped and how they should come to site?
Yeah, for the most part we do.
Yeah.
Yes, we tell them, how it should be packaged.
Okay.
Basically, protecting the flanges and stuff like that.
So you want to be the flanges, be end-capped and protected?
Right. And, be prevented from distortion and all that stuff.
Okay. Wonderful. I knew that was going to be the answer. And this is, what you should expect is that, we've seen equipment come from Canada all the way down to, it's going to travel 1,500 miles or so. And sometimes it's 30 degrees when it leaves Canada, and when it hits Texas, it's 80. And while it's going down the road, that tank is just expanding and swelling because it's changing temperatures just going down the road from the environment. So how it's shipped and how it's strapped down, how it's protected is important. Here's one we found. I would bet this is probably a $75,000 scrubber that you see here. I don't know how well this is basically a couple old tires and a piece of carpet. Okay, so if you just spent 75 grand on a vessel and it rolls up on your site like this, how concerned are you going to be of how well did it travel? At that point, I would almost say that you would probably want to do a very thorough internal and external inspection once you offload it, because you're just not really sure of how well it traveled, what the stability is.
Jeff, are there not requirements in the code to actually specify how the shipping should be handled?
Depending on what code you pick.
Okay.
So very good question. So if you pick RTP1 or like the Section 10 and the boiler code, absolutely there are shipping and handling requirements there. If you pick one of the ASTM standards, that's more about construction and not really, it doesn't go into those kind of details. So, excellent question. And that's, the standards are there for guidelines, and most of it keep you out of trouble. But it's important that you understand what's in the standards, because there are gaps in the standards. So where the standards stop, that's where your specifications have to pick up.
Jeff, I just wanted to add, it depends on, right down to the trucking company, because we've had, in my former company, they had a deal with, you know, Joe Smith Trucking, and the guy doesn't even know what FRP is. And so we had a brand new scrubber, and in order to make the turn at an intersection, he went up over the median. And when it slammed down, it cracked a brand new vessel all the way around. And so luckily we know to go in it before he drove away when he delivered it. But that's really still a shame, because whether you inspect it or not, you've damaged a brand new vessel, and then we start with the repairs. So most people don't know what FRP is. They think they're hauling a steel tank because it's painted and it looks like everything else that they've hauled. So sometimes you could have all that in the writing, and then they hire a trucker who decides to go through a canyon to get there. And really, it's stuff you don't even think about until it happens.
And that's very frustrating when you see that, because you see this great looking vessel and then all of a sudden something like that happens, and now basically your brand new vessel has got to repair before it even goes into operation. Steve, did you have something?
Most fabricators also have one or two trucking companies that they routinely use. A lot of end users have their own trucking arrangements, and so where we've seen problems is not when the fabricator selected the trucking company, but when the end user used a corporate agreement. And that's where the inexperience kicks in. But we've been very successful when we're allowed to use our trucking.
You know, there's obviously a lot of different ways to do things, and how, you know, everybody's kind of got their process. So I don't know if there's a perfect way, but it's definitely, I think the importance is that you have discussions about these, preferably in advance, just so there's an understanding of what they're hauling and how this is going to be handled, I think is the key. So I guess one thing that I wanted to say, I'm sure that a lot of y'all, whether you're you know, manufacturers or end users, have seen some of the older specs. You know, so the question is, you know, if you're, let's say if you're an owner and this is your specification, you know, what do you expect to receive when you from your specification? How do you view that? What do you expect to be delivered? Because this is the document that basically defines that for the manufacturer. So it's an important point. So I'm not going to reach out and touch anybody, but would like you to kind of think about that. You know, so some of the points that we would like to make is, you know, don't assume that they know what your expectations are. Again, are you looking for, you know, the least expensive vessel? Is quality an absolute priority for your operation? You know, don't assume that they, you know, they understand what your expectations are. You have to let them know, and only by defining it in your specifications are you going to do that. So you need to be very clear. You know, you need to expect documentation throughout the process, whether it's in the design, the design documents, the drawings, as well as the calcs. And you need to communicate the details. This is really what you know, what's important. If you you know, if your performance is your priority, you need to express that. We find as owners, as well as manufacturers, you kind of have three categories of operations. You have people that their principal priority is being cost conscious, that maybe it's a product that they run that is very low margin, or the market that they focus on, and everything is all about cost, doing it the cheapest way possible. And then you have this kind of middle group that's what I call the value-oriented group. So they want the best they can for their budget. And that's probably where the majority of, whether it be manufacturers or owners are. And then you have a smaller group on the opposite end that are totally about quality and performance. That from a plant side, it may be that safety is a priority, and for production, and they just can't afford outages. They can't afford leaks and spills, environmental incidents. They can't afford any safety concerns. If you're dealing with chlorine, toluene, and HCl, really easy to have very serious accidents that can injure employees. That's not tolerated anymore in a lot of places. And from a manufacturer side, it's just that we want to be the best. We want to be known to provide the best possible product in the industry. We want to be a champion for our industry and show people that it can be done right, and this is how you do it. So you kind of have these three groups, and as an owner, you need to kind of understand what category you're in, and there's not a right and a wrong. We all have to live within the framework that we're given, right? So it's understanding that they understand your priorities, and that you're picking people that you're going to match up. Because if you're a cost-conscious organization and you pick the guy that's only about quality, and really on his list, cost is probably maybe on the third rung and not the first rung, well, you're going to have a mismatch right there, and kind of wasting your time, because he's not going to be the cheap guy, or sometimes even competitive. So make sure that you're selecting vendors that are meeting your priorities, wherever you fit on that scale. So materials of construction, these are, again, this is kind of basic. You always want to have, resin, dual laminate linings if we're into that. Glasses need to be defined. One thing that I want to just touch on real quick here is when we define materials, if we define resin, we're going to say, this resin model or equal. So for intensive purposes, I'm going to say I want Hetron 922, Duracane 411, okay? And what you see a lot is you'll see or equal. Take some time and define exactly what you want. If in glass, in your veils, they should be defined equally well. There's a lot of manufacturers of glass as well. They're not all equal, just like any other material. It's like buying a car. Every car has four wheels, got a steering wheel, got a motor, four doors maybe, but you would not say that a Hyundai is equal to a Mercedes or a Ferrari, okay? And just like everything else, you have all that range of parts, and the materials is the same way. So take some time, find some resources, identify what the best materials are. Got a little bit ahead of myself already. So here is about resins, dual laminates. Dual laminates are much the same way. You have say CPVC. You're going to hear something about that here. What we have learned over time is that you have CPVC, PVC, FEP, all these different polymers that are used for dual laminate linings, for example. And what you find is that you have a sort of a raw material supplier like Lubrizol, who you'll hear from later today. But then they have molders beyond that. And then they have their own blends to the chemistry that they may modify slightly for making sheet, modify it differently to make tubing. They have different additives they add to for making fittings, say, or something else. And they're not always equal. The root chemistry is the same, but how they manufacture it and how they process it has a bearing on the performance. So you need to understand that that just defining it by the chemical description is really not sufficient any more than anything else. It's just basically saying, I need tires. You know, where you really want to be saying, I want Michelin, or I want Goodyear, or whatever. You know, we're going to move on a little bit. I'm running a little bit behind. You know, one thing that you don't see a lot of specification is fabrication tolerances. You know, in RTP1, for example, there's you'll see tolerances on body joints, like you see here, but not necessarily head joints. And then as well on like nozzle penetrations, for example. So if it's not in the standard, and these kind of details would not be in an ASTM standard. If it's not in the standard that you're selecting, well, that needs to be defined in the specifications as well. Because, you know, if you have a 1-inch gap here, well, that's going to become a weak point in your design once it's manufactured. Could be a point of future leak. So tolerances need to be defined well. You know, generally, you can see this is cut out by a Sawzall. What we prefer is to see most of your nozzles probably up to 8 or 10 inch cut out by a refined pour drill, where you're going to get probably something in the order of 1/8 inch tolerances in your holes. The tighter the fit is, the more, the stronger that joint's going to be, and the more solid it's going to be. There's going to be less flexibility, less chance for those joints to leak or break down later. And this goes on to tolerances in your drillings, nozzle alignments, nozzle alignments in your tanks and vessels, flatness of flanges, all those sort of things. We recommend certified welders. If you have dual laminate linings, certified thermoplastic welders. If it's FRP certified laminators. I'll give you my opinion. You won't find any discussion of this in the ASTM standards again. So you're kind of getting the theme here probably that we like RTP1 because it does define this. Beyond that, I would kind of go a little further and say that if you bought a steel tank, you would expect every welder on that tank to be certified. You probably wouldn't want that guy to be working on that steel tank if he was not certified. I would recommend that every laminator, every welder on any vessel should be certified. So that's our recommendations pretty much across the board. That's not necessarily, that's beyond what RTP1 requires. I will say that, but we think it's important. We think that pretty much we should meet the same sort of expectations that we see in the steel industry. And it's an important part of making a good quality product.
Who certifies? I mean, that's kind of open-ended statement.
Well, RTP1 has basically a procedure for certifying bonders and laminators. They can be
ASME.
It's RTP1 is a guideline, so ASME does not review the testing themselves. It's basically a plant administrated certification. But you can go back and look at documentation. Show me your certificates on your welders. Okay.
And I know like fiberglass pipe we can do B31.3.
Yeah.
Usually the manufacturer certifies that. So you're saying the tank fabricator regulates themselves and certifies for full people?
The same way.
Same way? Okay.
Yeah, ASME, for piping code, ASME is not reviewing that stuff either. They're just expecting you to have it. They leave that up to the owner to ask for that and put that in their specs. But the point is that to a great extent, everybody's working with resin. They're catalyzing the resins. They're working with glass. They're laying it out. So they really should all be certified in the fundamentals of it, as well as the detailed practices of laying down laminates. Greg?
Jeff, American Mall Society also just promulgated standard B2.4. We put that on the American Mall Society for the certification of well,
And that's what?
B2.4 that the American Mall Society.
Thank you.
Well, and ASME does audit the fabricators. The fabricators administrate the qualification, but then ASME comes in and audits to make sure they're doing it.
So yeah, ASME will send their auditors in, and these guys are boiler code auditors. So, and they're looking for everything to be tick and tied. They're looking for every piece of paper. So if you say that this is our process, they're looking for a paper that trains somebody on the process. They're looking for a paper on that procedure to complete the process. And they're looking for a test at the end of the process. And if they don't find that paper in there on that project and in your QC manual, you get, they basically get flagged on it. And then you got to go and fix it, and they're not going to unflag it and certify you for the next, set of years until that's corrected. Brian?
On the RTP1 certification, those critical test report, so the mechanical testing does have to be done by an independent lab. That can't be done by a fabricator. So there is some third-party independent involvement in that.
That's correct. Thank you for that.
Yes, for RTP1, do we have a procedure like in India? We are not heard of much on RTP1, except Sunrise made one job with RTP1 certification by overseas client, Total Engineering. So they insisted that we need to have RTP1. But beyond that, locally in India, we don't have any program which qualifies. Besides, the fabricator is working mainly on BS 4997. We are not upgraded to EN version also. So we would get some insight on what it will help us to move our fabricators to next level.
Well, primarily I'll say in North America, RTP1 is by far probably the most established and most well-defined standard. And there, I don't know, we're probably maybe up to around 14 or 15 manufacturers in America that are RTP1 certified. There are others that will say we build to RTP1. And I'll say they do make an effort to that. But until you are certified, you really don't understand what's involved, because just the depth of requirements and expectations and proof and documentation is pretty significant. I would hope that in time, maybe with more exposure in India, maybe RTP1 gets to be more established and manufacturers start to consider being certified in RTP1. In the end, it's the owners that are going to drive that. But the owners have to say, this is what we want, this is what we expect. We want everybody that we work with to be certified for RTP1, and that will begin to move the bar. But that's where it has to come from.
For this particular project, we had TUV as the third party certifying, but the project demanded RTP1. So TUV has been appointed as the lead auditor for working with Sunrise to see all the processes are being followed. So, but there is we don't have a certified RTP1 manufacturer or fabricator.
Right. So again, you're trying to meet the intent of it, but no one is certified. And it's done that way here too. In the U.S., we're established enough. Like I said, we have 14 or 15 manufacturers that are certified. As an owner, you know what you're getting when you get a certified vessel by RTP1. And less than that, you really aren't sure. I can tell you as a reviewer, somebody tells me that we go this in accordance with RTP1, but we just don't have a stamp. We'll go through the documents and almost right away, before you even start to pick up a brush or start winding, they've taken exceptions to RTP1. We take exceptions to material testing in RTP1. We take exceptions to this quality requirement RTP1, this documentation RTP1. Right off the bat, it's not the same. In India, they're refining their processes and expectations, and hopefully it will come. The more RTP1 is specified, we'll probably start working that way, I expect. So, just to kind of wrap this up, again, I think you should audit the shops prior to the bid to make sure you know who you're going out to. If you have specifications, I mean, if it were a steel tank, whether it be the owner or the owner's engineer, you've got somebody that's going to be reviewing calculations. If you're buying vessels, we think that somebody should be reviewing the calculations the same way as an FRP tank. And if you have in-house resources to do that, that's great. If not, then I would suggest that you need to reach out and make sure you're doing the same quality checks on this RTP1 tank as what you would normally do on a steel tank. Then, obviously, testing. I think Brian touched on this with respect to certifying laminators. Almost always you get man-weight cutouts of a vessel or a tank. Basically, when in the FRP process, you're bringing, basically, if you put it in steel terms, a steel mill and the fabricator together. So you have basically raw materials coming together and making the shell at one time. So it's like buying pipe and then they go and spool it together. In FRP manufacturing, all that's coming together in one place. So it's not until you actually test it on the man-weight cutout that you know that the design assumptions that were made for that in the counts were actually produced in the actual part. And again, the key is picking good bidders that have your same priorities, kind of going through some of these, and largely define your expectations. I would venture to say that for the most part, everybody's expectations are pretty high. We all want to have a car that never breaks down. We all want a vessel that you can sit there up on the pad and connect it up and it'll run for 30 years before you have to think about it again. Define what's important to you, and you're more likely to get it. So that's all I have. I think I ran over a little bit. We got to talk a little bit more. Are there any more questions?
I do have a question, Chair. I'll just look in here at your chair. You talked about design, calculation, fabrication, packaging, shipping, and handling and all that. You didn't mention anything about installation. Are there codes and standards or procedures on the installation side?
On installation, RTP1 just finds some things. I guess I'll say right off the bat that we're going to talk about a lot of different things over the next 2 days. So some things are going to be covered in more detail later. Only so much time we have to talk, so I can't necessarily hit on everything. And as you can see, I ran over anyway. RTP1 does define some expectations for installation, as far as things like what the pad needs to be like. There are connection and torquing requirements. Those sort of things are in there specifically. Specific test requirements on how the hydro should be done. It has to be AE tested. It defines standards for that if you want to go into an acoustic emissions testing. Those kind of things are in RTP1. Again, I would suggest that these are the fundamentals, and RTP1 has more depth. But when you have greater priorities or concerns, that's where that kind of stuff needs to be defined in your specifications.
I don't want to get a perfectly built tank or vessel delivered to my facility, and then a contractor takes it and make a mess of it.
Yes. Yeah. A simple example that I recall would be like related to piping, where piping's delivered, looks beautiful, you inspect it when it comes off the truck, and it's just piled in the dirt on the sides, and well, there's this big swale that gets washed out from rain or whatever, and then all of a sudden you go back a month later and all your pipe is looking like this because it's not been supported properly. That kind of stuff, that's a lot of lessons learned there, and that's the kind of things that need to be in the specifications.
Thank you, Jeff.